Today we are working on 5.6 linear inequalities. I've already got some stuff written out on here, so we're going to try to go pretty quickly through some of the introductional stuff, and we're going to get right into it. So our learning goal is that we can graph linear inequalities. So to start, we're trying to figure out if the ordered pair is a solution to the inequality, and that inequality is right here, this one right here. Okay, that's the one that we're trying to solve, that y is included in the inequality. So basically all we have to do is we have to plug in these points for the x and the y that I have highlighted up top, and you would get something that looks like this. The 2 goes in for the y, the -1 goes in for the x. That's why I have those different colored. The orange came from the point. And we just have to say if that's true or not. So is 2 greater than, this would be a -4? Is 2 greater than -4? Yes. Okay, so on to the next one. If I instead plug in -5 and -7, so what I would have, the orange, you can see that's where I plugged it in. The -7 went in for the y. So I would have -7 greater than -8. Is that true? Yes, it is. -7 is greater than -8. Next one. Is 3/6 a solution? Well, to figure that out, we've got to plug in... Oh, thought I was on my highlighter. We got to plug in 3/6. So that's what I did. As you can see in orange, that's what I have written there. And to solve this, so I have bring my 6 down, and then I'll have 2/3 times 3. Well, 2/3 times 3 is 2, because our 3's would end up canceling out. But you could do that on a calculator if you're confused by that. So it would be a 2 plus 4 is 6. Well, is that a true statement? Is 6 less than or equal to 6? Yes, it is, because it is equal to. Moving on. So now we have y equals 2x plus 1, which is just an equation. So we are going to just graph it. So we'll have a plus 1 right here. That's my y-intercept. That's the first thing that I'm going to graph. Then I'm going to rise 2, run 1. Rise 2, run 1. Rise 2, run 1. All the way up. And then I'm going to go all the way backwards as well. Okay, so fix my line here. There we go. And I can draw my arrow. Now the good thing is, on the next one, it's the exact same thing. If you look at it, they're the exact same thing except for one change, which is right there. Instead of an equal sign, we have an inequality. So keep that in mind. I've already got the points plotted out. These are the exact same points as the last one. I've got them plotted out, but this is what I'm going to do. First, I'm going to draw my line. Okay, and my arrow's on my line. And then secondly, now I have to do some shading. So in the past, our solution would just be the line, but now we've got like more points, we have infinite solutions to this equation. So for example, if I was just to ask you, okay, so how many answers would be like x is greater than 5? How many different numbers could you put in for x? A lot. You could put in infinite numbers. You could do 6, you could do 7, 8, 9, 10. Those are all solutions up until infinity. That's how many solutions there are. Same situation here. This is just a little bit more of a complicated equation. That's what we have here. We still have an infinite number of solutions, x's and y's, that would make that statement true. To find their location, we've got to zoom in a little bit more. I want you to notice how around 0, 0, that origin there, the origin is on this side of the line, right? So our line doesn't go exactly through the origin. So what I'm going to do is I'm going to take that point 0, 0, and I'm going to plug it in for my equation. I'm going to plug in a 0 for y. I'm going to plug in a 0 for x. So there's me plugging in my 0 for y. If I plug in a 0 for x, it's going to be 2 times 0 plus 1. 2 times 0 plus 1 is 1. So then I just got to figure out, is that a true statement or not? In this case, that is a true statement. 0 is less than 1. So since it's a true statement, I'm going to shade the side where 0, 0 is on. So let me change colors here. Since 0, 0 is on this side, this is the side that I am going to shade. There we go. What does that mean? That means I could pick any point that's right here, right here, right here, right here, right here, right here. Any of these points, you could plug them in for your x and y in that inequality, and they would be true. Okay, so let's move on to the last one. If I look on the last one here, there's not really any difference between the two. So if I erase this really quick, the only difference is where we had an equal sign there, now we don't have an equal sign there. So it's literally the exact same thing. The only difference is instead of a solid line that I have drawn right here, that's a solid line, we're going to go dashed line like this. Okay, that's it. We can take our shading, and shade. You would just lightly do this with a pencil, but you can lightly shade this side, meaning the same thing as the other one. Any of the points that are in the shaded region would work. So what's the difference between these two? If they're exactly the same except the dotted line, what's the difference? Here's what it is. If I pick a point that's on the line, and I know I kind of colored over it, it's not a very good line anymore, but if I picked a point that was on the line, let's say that was one of the points that's on the line, that point would make this statement true. Any point that's on this line would make this statement also true. You would get something probably that's like 6 is less than or equal to 6. And that's true, but that's barely true, right? That's barely true. Whereas over here, if I pick a point that's on the line, that's not true anymore because we would have, for example, 6 is less than 6, and now it's not true. So that's the main difference. Where it was once 6 is less than or equal to 6, now it's no longer equal to, and so the line doesn't count anymore. So down here, I'm just going to write this down really quickly. We will have, this is just showing, these are going to be the dashed lines if you have these types of inequalities. And if you have the equal sign, it's going to be a solid line, and you can draw your arrows on those to remind yourself. Let's go through some examples. So I've already got my lines drawn. I'm not focusing on going through and drawing the lines on the graphs. I just want to focus on the final product here. So on this one, it's going to be a dashed line. You guys can go through and plot your points, making sure like this is your y-intercept at -2 and all of that. But I'm going to draw my line, and this is going to be a dashed line with arrows. And then my shading, I've got to go through and plug in, again, 0, 0. I choose 0, 0 because it's the easiest point. If the line goes through 0, 0, then obviously you can't choose it because it's got to be on one side or the other. But this one is, the line's not going through 0, 0, so we can use it. So if I plug in a 0 here, and then 0 minus 2, I'm plugging in a 0 for x, that would make a -2. Is that a true statement? The answer is yes. So we are going to shade this side of our line. I want to get as close to the line as I can without going over it. Shade it up. We're good to go. Okay? Next one. Again, I already drew the line in there, or I drew the points. I just have to draw my line now. So I'm going to draw a solid line for this one. And I'll put my arrows on the ends. And now 0, 0 is on the bottom of that line. So if I plug in 0, 0, 1/2 times 0 is 0, plus 1 is 1. Is that a true statement? Yes, it is. So let's shade the 0, 0 side. We're only shading the 0, 0 side if it's a true statement with 0, 0. Otherwise, we'd have to shade the other side. But that one is a true statement, so we'll shade it. Next one. Got my line drawn already. I'm going to go through. Oh, by the way, yeah, I guess I have a lot of work up here that I should explain. I changed this one into a different form. It was in standard form, but I changed it into slope-intercept form. And the only reason I did that was because I can't cover up, like, I can't cover up a part of it and say, okay, so my x-intercept is 15, because that would be, like, way over there. So it wouldn't fit on my graph, so I had to change the form on this one. So that's what I got for changing my form. I highlighted it there. And now I'm going to draw my line. And it's a dashed line. So make it a dashed line. I kind of messed that up. Let me try again. Okay, there's my dashed line. And I'm going to shade it now by plugging in 0, 0. Well, I like to plug in 0, 0 to the original because look what happens here. We have 0 plus 3 times 0. So we've really got 0 is less than 15, which is a true statement. So we're going to have to shade the side with 0, 0 on it. There we go. I think we're going to move on to the next page here. Okay, here we go. So if it's an x is greater than 1, we don't have a y in there. This is just like an x equals -1 line, which is a vertical line. And I'm going to plug in 0, 0, except obviously I can't plug in the y value, but I can plug in 0 is greater than -1, which is a true statement, meaning I'm going to have to shade the side with 0, 0 on it. I've already got my dashed line there, as you can see. Okay, on to the last one. If I plug in 0, 0 here with this line that's going through the y-axis at 2, if I plug in a 0, is 0 greater than 2? Hey, this is our first false one. 0 is not greater than 2, so we are not going to shade this side with 0, 0 on it. We're going to shade the opposite side. That's up here. There we go. We have it shaded. Next one. We have a multiple choice. It says, which inequality represents the graph at the right? Well, I know it's not D, because D has an inequality without an equal sign. And this one's going to have an equal sign because we've got a solid line over there. Next, I know it's not going to be B, because my slope here is rise 2, run 1. Which means my slope would be 2, and this one only has a slope of 1x. So it can't be B, which leaves me down to A and C. So what I'm going to do, based on the shading here, based on the shading, it looks like 0, 0 is one that would be true. So we have to plug in 0, 0 to both A and C and figure out which one makes 0, 0 true. Because they're the exact same thing, except their signs are switched around. So if I plug in 0, 0, plug in a 0 there, and plug in a 0 here, I'm going to get 0 is less than, well, 2 times 0 is 0, plus 1 is 1. Does that make it a true statement? It sure does. Now you can take my word for it, or you can go into the other one and try it over here, but it would not be a true statement for letter C. I think you would get 0 is greater than or equal to 1. I forgot my equal sign over there, but you would get 0 is greater than or equal to 1, which is not a true statement for 0, 0. And since it's shaded, we have to make it a true statement. Last problem here. You budget $200 for wooden planks and outdoor furniture. Cedar costs $250 per plank and pine costs $175 per plank. So I tell my students I like to find the total first and put it by itself. I have a total of $200 to spend. I don't know why I put an equal sign there, because we can spend less than 200. 200 is a maximum. So I'm going to use an inequality with an equal sign, because we can spend exactly 200 as well. So my x and my y are going to be number of planks but it's going to be number of cedar planks for X and number of pine planks for Y. That means my equation is going to be $2.50 for cedar planks. How many are we buying? We're buying X cedar planks plus $1.75 for every pine plank, and that's our inequality there. So it says you buy 20 planks of pine, up to how many cedar planks can you purchase? So I'm going to plug in 20 for Y, since that was my pine. So I'll have $2.50 times X plus 175 times 20 is less than or equal to 200. Then we got to do a little bit of math. I don't really have a calculator right now, so we're going to have to try our best here. So $2.50 times X, 250X plus, well, you might have to do this one on your own, I guess, if I don't have a calculator, but you'd multiply these, obviously, and then you're going to basically just solve for X. So I'll let you guys finish that up.